Hi students, in this video we are looking at applying angle theorems again. This is part 2 of our series looking at applying angle theorems. If you haven't seen the first part yet, it would be worth stopping this video and watching the first part before continuing on this one, because we'll be talking about some theorems covered in that video in this one. So learning goals. So after watching this video, you should be able to apply the second two angle theorems to calculate unknown values. So some things to recall, like I've already said, if you haven't seen part 1 of this series in applying angle theorems, go and do that first. But it's also important you know the different parts of and terminology related to circles. So that relates to things like chords, diameters, sectors, segments. Being familiar with those words will be helpful. Carrying out geometric proofs will be helpful, and also those symbols that we use in those proofs. Recalling those will be helpful in going through some of these examples. Alright, so angle theorem 3 states that angles subtended by the same arc are equal. Now this rule is built on angle theorem 1, which we looked at in our last video. So that says that if you've got an angle subtended at the center by some arc, that angle is twice the size that the arc subtends at the circumference. So this angle at the center is double the size of the one at the circumference. What I'm going to do is draw in some construction lines here. Let's say the center is about here. And draw in some construction lines for that chord. Now looking at this left-hand side here. Okay, looking at this left-hand side here, the angle in the green, right? We can just call that 2A, because we know that angle at the center will be double the angle that's made at the circumference. But now looking at this right-hand side chevron or arrow shape, right? It's got the same angle at the center, 2A. So at the very top, that angle must be A as well, because it's subtending, it's an angle at the circumference, and it's got the same arc as this 2A angle here at the center. So both of those angles at the top must be the same. Now, funnily enough, you can also show that these angles here at the bottom are also exactly the same, because once again, they're subtended by the same arc, this one here. So the angles at the top and the angles at the bottom are both the same, and the symbol we use for that is just like the one we use here. We've got the triangles. There's our symbol that we use to justify our angles and that we can use as proof in our geometric proofs regarding circles. So looking at an example here, right, we've got A and 25 here. Those angles must be the same because they are angles subtended by the same arc, using that symbol there. And that's all there is to it. Those angles subtended by the same arc, they must be equal. Now, our fourth and final angle theorem has to do with cyclic quadrilaterals. Now, cyclic quadrilaterals just shapes, quadrilaterals obviously, where every corner is on the circumference of a circle. So this point's on the circle, so is that second, third, and fourth point. They're all on the edges of that circle, so we can call this shape a cyclic quadrilateral. Now, the rule for, or the theorem regarding cyclic quadrilaterals is that opposite angles are supplementary. Now, supplementary, just remember, means they add up to 180 degrees. Now, I won't do a proof in this video, but you can find one of those proofs in my Lightboard videos, which you can access through the banner or through my About links as well. You can find a proof for this angle theorem. So these opposite angles add to 180, but also these opposite angles also add to 180. Right, so looking at how we use this in an example. So here we've got our example, we've got our cyclic quadrilateral. We can see all the corners are on the circumference. So opposite angles must add to 180 degrees. So we can say 95 degrees plus b equals 180 degrees. Our symbol is just a quadrilateral inside our circle, so that means b must be 85 degrees. We can also say, because they're opposite, 80 degrees plus a must also equal 180. Rearranging that, we get 100 degrees. And once again, our reason for that statement is our circle with a quadrilateral in it that says opposite angles of a cyclic quadrilateral add to 180 degrees. And that's all there is to it for calculating unknown values in cyclic quadrilaterals. Alright students, so after watching this video, you should be able to apply our second two angle theorems, 3 and 4, to calculate unknown angles.